Today in class, you're learning about how to find the area of compound shapes. The essential question is, can you find the area of a shape that is made up of two or more simple shapes? That brings us to our first definition. So a shape that is made up of two or more simple shapes, that is a compound shape. And I've also seen them called composite shapes. So you can call it a compound or a composite shape. To find the area of a compound or composite shape, same thing, you just divide up that shape into simple shapes and add the areas of each together. So review from our notes, the last notes we've taken, we talked about how to find the area of squares, rectangles, triangles, and circles. So that's what we're going to go ahead and fill in here. So just from memory right now, I want you to write down how to find the area of a square. Okay, pause the video and try to fill out this whole entire table. Okay, so I'm going to go ahead and proceed. So the area of a square, I know you can go ahead and count the boxes if you can see them inside the square to find the area. However, sometimes, obviously sometimes you're not going to have those boxes visible. So one way you can do it is take the length of the square and multiply it by the width of the square. Or you could also say base multiplied by the height of the square. Same thing. Okay, same as the rectangle. Just like the square, it's just length times width. Or you could say base times the height. Okay, a triangle. Since a triangle, if you took a triangle is basically half a rectangle or a square. So if you had like a rectangle and you were to cut the diagonal straight across, so you'd end up with the triangle. So if I'm just trying to find the area of just a triangle, you would go the length times the width and then just divide it by 2 to get the area of the triangle. So there's a couple ways you could write that. You can go length times width divided by 2. Or you could write it as base times height. And I should have mentioned this. I don't have to put the multiply sign in between it. If I just would smush them together like this, that means length times width because they're variables, and then when they're smushed together like that, that means you multiply. Anyway, I can go base times height divided by 2. Or there's other ways to write this because dividing by 2 is the same as multiplying by 1/2. So you could also basically write it as 1/2 times the length times the width. There, I'm not going to put the multiply sign in between. All this means multiply. 1/2 times length times width. Or you could also write it as 1/2 base times height. I think if you were to Google what's the area of a triangle, they would probably write it like this, 1/2 base times height. But all these are equal to each other. Okay, so pi times the radius, or we could say pi times the radius to the 2nd power. Or if you want to do shorthand for it, it's pi r squared. Okay, and that is the area of a circle. All right, now a semicircle, it's just a half a circle. So area of a semicircle, you would just take the exact same area of the circle, so pi times radius squared, and then all you do is divide it by 2. Similarly, if you had like a quarter circle, a fourth of a circle, pretend that's a fourth of a circle. So it's basically a half of the circle cut in half. That area would be pi radius squared divided by 4. Okay, so that's for a quarter of a circle. Okay, and yep, you do need to know that. Semicircle and quarter of a circle. How to find the areas of those. For your summary, I want you to draw a compound shape. Draw me a picture of a compound shape. Okay, let's move along. Take this knowledge that you have about just simple shapes and apply it to finding the areas of compound shapes. So here's an example of a compound shape. You'll see that it's composed of like a rectangle and a triangle smushed together. And it says in the directions, round to the nearest hundredth if needed. And that's important that you know how to round to the nearest hundredth because when I was looking at the interim assessment answers, they will count you wrong on the SBAC if you round it incorrectly. So if they say to round it to the nearest hundredth and you round it to the nearest tenth, then they will mark it wrong even though your answer is technically correct. You really, really have to pay close attention to the directions, okay? So just like on the first page, it said to find the area of a compound shape, you just break it up into stuff you know. So I don't know how to find the area of this weirdo shape, so I'm going to cut it into a rectangle and a triangle. So I know for this I need to do length times width for this guy. Plus, for the triangle, I need to go 1/2 base times height. Okay, to find the area of that. So length times the width right here, I would go 13 times 8 plus 1/2. And then the base of this triangle is going to be 8 inches. And the height of it, so from here to here, I would have to go 19 minus 13, and that would give me 6 inches. So the height of that triangle is 6, and that's going to give me the area. So 13 times 8 is 104. Let me know if I mess up, okay? I do have like a pre-written answer key, but it's super sloppy. And I was doing it when Barrett was playing around me. And there's a chance I probably just overlook stuff. So call me out if I'm wrong. You get prizes. Okay, half of 8 is 4. 4 times 6 is 24. So our area is going to be 128 inches squared. Don't forget to label it inches squared because it tells you how many squares are in it. That's area. Whenever you're dealing with area, you label it square inches or inches squared. So another way I could write this is 128 square inches. That means the same thing. Okay, here's another composite shape. So I'm going to just divide it like that, I guess. So I can go, let's see, length times width, plus the length times the width of this, plus the length times width of that to get the area. And so that would be, so that's, this whole thing is 12, half of it. There, it looks like that. So length times width of this one would be, actually I could just multiply, I'll do all the work. Plus length times width. That's going to give me the area. Well, that's 36 plus 36 plus 36, which would give me the area. Oops, I guess I can add that right now. 108 yards, I'm abbreviating, squared. Okay, right here, let's see, oh look, it's a semicircle and a rectangle here, okay? So radius of a semicircle, so from here to here, half of 8 is 4. Okay, so I have to go, I'm going to find the area of that first. Pi radius squared, then divided by 2 because it's a semicircle, plus length times width. And that's going to give me the area of that shape. So pi r squared, so pi times the 4 squared divided by 2 plus 12 times 8 to get the area. So 4 squared is 16, so it's 16 pi divided by 2 plus 12 times 8 is 96. That's going to give me the area. And I see that I can go 16 divided by 2 and get 8 pi. I got 8 pi because I went 16 divided by the 2, which is 8, and the pi is still there. That's going to be the area. And this right here, rounded to the nearest hundredth, these multiplied, is 25 and 1300ths plus 96, and that's going to give me 121 and 1300ths feet squared. Now, I'm pretty sure I used the pi symbol on my calculator. So if you were someone that didn't have the pi symbol on your calculator and you used 3.14 to represent pi, your answer should have been like, this. Okay, see how it's just slightly different? I use like real pi, but that's in my calculator, you know. And if you use 3.14 instead of pi, then you'd probably get this as your answer. And both are acceptable. And make sure you round to the nearest hundredth. It's to the hundredth place. For your summary, I want you to answer this. What's the formula to find the area of a triangle? And please be sure to label the formula, okay? The shape is made up of a triangle and a semicircle, so I'm going to start with that triangle first. So I know area of a triangle is 1/2 base times height. I got to add to that semicircle, so area of the whole circle is pi times radius squared. but you have to divide it by 2 because it's a semicircle. And that's going to be the area of that compound shape. Go ahead and substitute the values in right here. So 1/2. The base of that triangle is 8 feet. The height is 7. Plus pi times, okay, the radius right here, if the whole, the diameter is 8, the radius is 4. That's 4 squared divided by 2, and that's going to equal the area. That says area. That really does say area. Okay, so half of 8 is 4. 4 times 7 is 28. Okay, so this would be 4 squared is 16, so it's 16 pi. I could have wrote pi times 16, pi 16, that's cool too, but that looks funny. Okay, so 28 plus, okay, 16 divided by 2 is 8. Don't forget the pi. Okay, and then 8 times pi when I typed it in. So this is the calculator I used in high school. So when I go 8 pi, got that round to nearest hundred is 25 and 13/100. So 28 plus 25 and 13/100 equals, the area would be, when you add them together, 53 and 13/100 feet squared. And if you use just 3.14, you get 25 and 12/100 plus the 28. 53 and 12/100. See how it just varies slightly? So if you use 3.14, your answer would have been 53 and 12/100 feet. Is it feet? Yeah, feet squared. Okay, this composite shape, I'm just going to divide it like in a rectangle and a square, I guess. Yeah. So for this rectangle, it's going to be length times width plus that square, length times width, and that's going to give me the area of this composite shape. So I'll start with this one. So 11 times 4 plus 5 times 5 will give me the area. It's 44 plus 25 would give me 69 centimeters squared. Okay, we're gonna skip right now. We're gonna skip the story problem because it's gonna, I wanna spend more time on it, and I wanna make sure that you can totally find just area of composite shapes first. This is something you are gonna see on the quiz, and when I was looking for quiz questions, I was looking in the example problems for the SBAC, and it's very similar to something that you'd see on the SBAC. So it's a little bit, it's higher level than the stuff we're working on here. And I wanna make sure you're able to do this before you can approach this, because I don't wanna burn you out. Okay, so let's skip that for now and we'll come back to it. And let's look at number 7. Okay, these ones are a tiny bit different because it says you gotta find the area of each figure's shaded region. And of course, round your answers to the nearest hundredth if necessary. So the shaded region is that darker spot right here. Hopefully it photocopied correctly. So with these, the approach I would take is I would take the area of the larger rectangle and subtract the area of the smaller rectangle, okay? And that's what we'll do. So I'm gonna take the area of this. How would I find the area of the big rectangle? I would just go length times width, and then I would subtract this one's length times width to get the area of the shaded, okay? So the big one is 11 times 8 minus 9 times 6, and that would give me the area of that shaded region. So 88 minus 54, and that would give me 34 inches squared for the shaded region, okay? Okay, right here, I think what I would do is I would take the area of this big whole thing and subtract the area of this little cute square right there. So for the big thing, that'd be length times width minus the cute little square, length times width, and that would give me the area of the shaded region. So the big thing is, what does that say, 8 times 12 minus 4 times 4. That'd give me the area of the shaded region. So 8 times 12 is 96 minus 16, and that is 80, and it's in centimeters squared. Okay, we're gonna skip number 9 for right now. Can't turn the page. Okay, so here it's just the area of the shaded region. It appears I can just take the area of that rectangle and then subtract the semicircle right there. So it would be for the rectangle, it's length times width minus, that's a semicircle, so it's, for a whole circle, it's pi times radius squared, but then you gotta divide it by 2. Okay, and that's gonna be the area of the shaded region. So length times width, so 13 times 6 minus pi times, okay, radius. So if this whole side is 6, then half of it would be 3. So 3, don't forget to square your radius. Squaring means 3 times 3. Divide by 2, and that's going to give me the area. So 13 times 6 is 78 minus 3 squared. 3 to the second power is 9, so it's 9 times pi over 2 would give me the area. 78 minus 9 divided by 2 is 4.5 times pi equals area. And what you do here, when I multiply this right here times pi on my calculator, I got 14 and 1400ths, which would give me approximately 63 and 86 yards squared. And if you use 3.14 to represent pi, your answer should have been 63.87 yards squared. Both are acceptable, okay? All right, so here for the area of the shaded region, you take the area of that whole rectangle and subtract the area of that triangle. So for the area of the whole region, it would be length times width, because it's a rectangle, minus, now the triangle is 1/2 base times height. And if you don't have these formulas memorized, you need to memorize them, okay? All right, so length times width, 7 times 6, minus 1/2. The base of the triangle, oh, I almost made a mistake. All right, sorry, so the length is 10, not 7. Okay, 10 times 6, okay, minus 1/2 base, the base of the triangle is 7, times the height of the triangle is 6. Okay, so 10 times 6 is 60. See, half, I can go half of 7, but in my head I like it better if half of 6. That makes more sense in my head. Half of 6 is 3, and then 3 times 7 is 21. And 6 minus 21 should be 39 meters squared is the area of just the shaded region. Okay, and now let's go ahead and tackle those more challenging problems. These examples are ones where you actually have to use what you know about the area and make a decision. All right, so let's start with number 6. And please review this. You will see it again on an assessment. So Nicholas needs to paint this figure. He knows 1 can of paint covers an area of 24 square feet. What is the fewest number of cans of paint he can use to paint the figure? And they're giving us a hint. 1 meter is approximately 39 inches. Because this right here is measured in meters, and the information they give us is that 1 can of paint covers an area of 24 square feet. See how we have, unlike units here, we've got a lot going on. So that's why I saved these problems for last. So we know for sure that we need to find the area of this figure right here. And it is a composite shape, so I know I could break it up. Let's go ahead and figure out the area. And I want to give myself some room here, so I'm going to write off to the side. So the area, I'm going to start with the area of the triangle. It's going to be 1/2 base times height plus length times width. That's going to give me the area. So 1/2, the base of the triangle is 7. The height of the triangle, just right there, is 11 minus 7, which is 4 meters. Plus the length times width, so 7 times 7. Okay. I go half of 7 and get 3.5, but I don't want to do that because I don't want to go 3.5 times 4 if I'm doing it in my head. So I'm going to go half of 4, which is 2. 2 times 7 is 14. Plus 49, and that's going to give me 63, and this is in meters. Okay, so that's the stuff we've been working on. You should have gotten that. It shouldn't be that hard for you after you've done all these practice problems. But they give us this information here. remember Nick's got to paint this, and 1 can of paint covers an area of 24 square feet, but we're dealing with meters. So I need to convert these meters using this hint here. 1 meter is equal to approximately 39 inches. Once I get it into inches, then I can get it into feet and then determine how many cans of paint are needed. Okay, so this is where I'm gonna like chime in with the, write that hint here. I gotta remember 1 meter equals 39 inches. Okay, so I'm gonna take this 63 meters, and there's 39 inches in one of them, so if I have 63 of them, I need to go 63 times 39. But listen, if I just go 63 times 39, remember how it's 63 square meters? If I only go times 39, I'm only multiplying basically like one side of it. I need to multiply both sides of it by that, so I need to go times 39 squared. And that's going to give me the area in inches squared. Okay, this is very important that you do that. If I just went like that, that's going to be wrong. Okay, because remember, we're dealing with area here. Okay, so this would be 63 times, when you go 39 times 39, you get 1,521. And the area in inches squared is going to be 95,823 inches squared. Okay, cool. We have it in inches, but remember, our information has to do with square feet. So I need to go from inches to feet now. Okay, so with that being said, I know that I need to take that value, 95,823, and I know that there are 12 inches in 1 foot. Okay, so if I have this many inches, I need to figure out how many feet are in that many inches. So I need to divide by 12, and not just 12, it's got to be 12 squared, because we're dealing with area here. Okay, if you just divided by 12, that would be inaccurate. We're dealing with squares. When I divide it by 12 squared, this is going to give me the area of this guy, this whole composite shape, in feet squared, or square feet, same thing. Okay, so this would be 95,823 divided by 12 times 12 is 144. When you take that divided by that, the area of this composite shape is 665 and 44/100 feet squared, or square feet, same thing. Okay, now we have it in feet. We have this information in feet. The next thing I got to do to figure out how many cans of paint is, I need to divide it by 24 feet squared. Divided by 24. And look, it's already in square feet per can. So I don't have to square this. It's already it's already in the squared units. Okay, so when I divide that, I get approximately 27.73 cans. But you can't have 0.73 of a can. So if he only had 27 cans, he couldn't finish the job. He needs 0.73 more of a can to finish the job fully. So when you're going to the store, he's going to have to buy 28 cans. And that's the answer. So it was a very, very long process, you know, but it's basically real life. Like you'd have an area to cover. Sometimes you need to paint it. If you were the person doing this in real life, you'd probably measure this in feet because you know your can is dealing with square feet. But the SBAC likes to make things a little more complex so that you exercise your thinking and show that you really understand what you're doing. So I understand that you're probably like, what just happened? You need to pause or stop the video, try this on your own, see if you figured it out. That's how you study for math, okay? Rewind, get out a blank piece of paper, and try it again, okay? For your summary, please answer this. How do you find the area of a semicircle? I'm going to show you how to do number 9 now. Okay, Marissa needs to paint the shaded region, just the shaded region. She knows that 1 can of paint will cover an area of 60 square inches. What's the fewest number of cans of paint she needs to paint the shaded region? Okay, so let's first off start by finding the area of just that shaded region. So you would take the area of that, it's a square, and subtract the area of that circle. So I'm going to just go ahead and put up my equation for that. So it would be length times width minus, okay, area of a circle is pi times radius squared. That's going to give me the area of that composite shape in feet squared. So length times width, 8 times 8, minus pi, okay, the radius is going to be half of 8. The 8 would be the diameter, so half of 8 is 4. From there to there is 4 feet. 4 squared would give me the area in feet squared. So 64 minus 4 squared is 16. This is 16 pi minus equals the area. So 64 minus, you can't just go 64 minus 16. You can't. Remember, like terms, this is kind of like a term right there. So you got to go 16 times pi. And when I did that in my calculator, I got about 50.27. And that's going to give me the area, which is 13 and 7300 feet squared, or square feet, same thing. Okay? But the information they give us here is it's in square inches. So there's a couple ways you could do this. You can convert this right here to square feet if you want. But since I saw how it would be like on your quiz, which I copied right from the SBAC practice test, I'm going to just do the whole process of converting it from feet to inches, the area, okay? You can go ahead and try it the other way if you can think of that other way using converting this to square feet, and you'll get the same answer. Okay, so anyway, this right here is feet squared. I want to convert it to inches. I know that there's 1 foot equals 12 inches. So I take that 13 and 73 hundredths feet squared, and I'm going to multiply it, because that's how many feet it is. And I know there's 12 inches in 1 foot, so if there's 13.73 feet, I need to multiply it by 12. And you got to square it, okay? Because they're square feet. These are square feet. Okay, so you have to multiply it, like both sides of the square foot. Okay, got it? So that would give me the area in inches squared. So 13.73 times 12 squared is 144. When I do that, you should get 1,977 and 12 hundredths inches squared. Okay? So they tell me that 1 can will cover 60 square inches. Well, this is how many square inches are there total, so I need to divide that by 60 square inches. I'm going to divide it just by 60. See how it's already in square inches? This right here was not in square inches. It just says inches. You got to square those inches right there. That's why I did that. This one is already in square inches, so that is why I'm not going divided by 60 squared. It's already in that unit, okay? So this divided by this is approximately 32.95 cans. However, you can't buy 0.95 of a can. You probably, yeah, you're definitely going to need to buy 33 cans of paint. And that's your answer, okay? Because it says, what's the fewest number of cans of paint Marissa needs to paint that? And it's 33 cans, which are needed. Okay, pause that, rewind it, seriously. Get out a blank sheet of paper and try it on your own. That's really the only way that you can, well, one of the only ways that you can really see if you can do it by yourself, okay? You have the answer right there. See if you can do it.
You guys have a lot.
For your summary, it says, how do you find the area of a rectangle or square? Okay, number 12. Zoe needs to paint the shaded region. She knows that 1 can of paint covers an area of 24 square feet. Oh, that pops up again. That's kind of a hint for you. What's the fewest number of cans she needs to paint the shaded region? 1 meter equals about 39 inches. Okay, so I'll start off by finding the area of that shaded region. So I'm going to start with the circle, area of the circle, and I'm going to subtract that area of the triangle. Area of a triangle is 1/2 base times height, and that's going to give me the area of that figure in meters squared. So pi radius squared. So if this whole thing is 16 meters, then the diameter is 16 meters, so the radius is going to be 8 meters. Okay, so let's set this up. Pi times 8 and squared minus 1/2. The base of the triangle is 16. The height of the triangle is also the radius of the circle, so that's 8. That's going to be the area of that shape, of the shaded region. So 8 squared is 64, so this is 64 pi minus, okay, half of 16 is 8. 8 times 8 is 64. And that's going to give me the area. You can't go, oh, 64 minus 64 pi minus 64 is pi. No, it's not. These are not like terms. See how this has got that? It's basically kind of like It's a variable that we know. It's like attached to it. We know this is approximately 3.14159, blah, 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 blah. So you got to multiply that first, okay? So this right here is about 201.06 minus 64. And when I subtract those, I get 137 and 600 meters squared. It's in meters, okay? So just giving you kind of a hint, you will see on an assessment where you're going from meters, and then you got to take it down to inches given this information, and then from inches you got to take it to the feet to figure out how many cans you need, okay? Okay, so right here, I'm in meters. I need to go down to inches, and they give me that hint right there. They tell me 1 meter equals approximately 39 inches. Okay, so I'm going to take this value in meters, and 1 meter equals this many inches. So if I have this many meters, I need to multiply it by 39 inches. But these are just inches. It doesn't say inches squared, so I got to square these. Okay? And that's going to give me the area in inches squared. So when I go 137 and 600ths times 39 squared is 1,521. That answer is giant. Or not that giant, but it's big. 208,468 and 2600ths inches squared. Okay, great. So now we're in inches. Well, you should know that, how many? Let's see, we gotta go to feet. So there is 1 foot is equal to 12 inches. Okay, remember that? 1 foot, there's 12 feet and 1 inch, or 12 inches in 1 foot. So you're gonna take this value right here, and you need to divide it, because this is how many inches there are, and there are 12 inches in 1 foot. So if there's this many inches, we need to figure out how many feet are in that. So we're going to divide it by 12, but 1 foot equals 12 inches, so 1 foot squared is equal to 12 inches squared, okay? So we need to square those 12s, okay? And then when you do that, that's going to give you the area in feet squared. So 208,468 and 2600ths divided by 144, because 12 squared is 144, it'll give you 1,447, 1,447 and 70 feet squared. Okay, so that's the area of the shaded region in feet squared. So from here, we got to figure out this part. 1 can covers that many square feet. Here's how many square feet we have. So we got to figure out how many cans that is. Take that number and then divide it by 24 feet squared per can. Because it's already squared. It's already square feet. So I don't need to multiply 24 by itself. I don't need to square it. Okay. So when I do that, I get approximately 60 and 3200ths cans that are needed, but she is actually going to buy 61 cans. Okay, practice those problems. And if you have specific questions, you can't just come to class and say, I don't get it. You have to tell me what part you're not understanding so that I can help you better. If you just come and say, I don't get it, I don't know what else I could say besides what I've already said. But if you're saying, well, Hopkins, why are we having to multiply it by 39 squared? I can explain that. So be specific when you're asking your teacher questions, okay? Your summary asks, how do you find the area of a circle? All right, last but not least, on this back page, yes, fill it out to receive points for these notes. Which problem was most challenging for you? I can kind of take a guess which ones were. What did you learn about solving that problem that will help you in the future? So examine that problem that was challenging for you, and remember those things that you need to, remember those things that confused you so that when you confront this problem again, you won't be confused. And which problems do you think will be on the quiz? And then do you still need help with any of those problems? Yes or no? And will you come in for extra help from Mrs. Hopkins during lunch? So if you tell me you still need help, yes, but you won't come in, that's kind of your fault, okay? Because if you need more one-on-one time to work on this specifically, I can't really take up entire class time just to help one person. All right? Okay, so do what you need to do and advocate for yourself. Okay, have a good day. Bye.